Up to this point, you guys, we have been working with events that are this and that. Today we're going to look at ones that are this or that, with the probability of rolling a 1 or a 6. Okay, so we're going to deal with or. And when you deal with or, we actually are adding probabilities versus multiplying them. Okay, we're going to have two different types of or situations, though. You have it where it's called mutually exclusive, meaning there is no connection between the two. Or we have it where it's inclusive, where there's some sort of relationship. Okay? So we're going to have two different items here we're going to look at. First is what's called a simple event, and that just consists of one event. Bless you. Okay? And you can't break it down into smaller events. Okay. Then we have what's called compound event, and that is where you take two or more events. Okay. All right. And when you have two events, so when you have more than just one, you have to understand how they relate before you find the probability. If there is no overlapping connection, then we have what's called mutually exclusive. If there is some sort of relationship between the two, then it's called inclusive. And so depending on which one it is, you're going to do something different. Okay? So let's look at, we're going to look at a deck of cards. So again, how many cards are in a standard deck? You guys remember? 52. Okay? And so it wants to know what's the probability of drawing a 2 or an ace. Okay? So the question is, can a 2 be an ace or an ace be a 2? No. So there is no correlation between the two, so we call that a mutually exclusive event, okay, where there's no overlap or correlation. Okay, so you can't be a 2 and you can't be an ace at the same time. It's not possible, okay? However, if it was hearts in a 2, you could be a 2 and a heart, right? You could have a 2 of hearts. Right? That is when there is a correlation. Okay? So when the two cannot either, there's no relationship between the two, it's called mutually exclusive. Okay? And so when we're working with mutually exclusive, okay, we're going to have it where we have two events, A and B, which is like the 2 and the ace. Okay? And how we actually find the probability of that occurring is where it's the probability of A or B. Okay? So it's like 2 or an ace. Okay, in this situation. Then you're going to do the probability of the A plus the probability of the B. Before we were multiplying, now we're adding. Okay? So we're going to find the probability of 2, and we're added to the probability of an ace. Okay? So how does that work? Well, let's look. So the probability of drawing a 2, or, and the key word right here is or, an ace, okay, is you're going to find what these are. So we know that there's a total of 52 cards in a deck, right? How many 2s are there in a deck? There are 4 in a deck. And then how many aces are in a deck? 4. Okay, so we have 52 cards, but we have a total of 2, and we have a total of 4 2s and 4 aces. So we're going to do the probability of a 2. So the probability of 2 is the successes of a 2. So we have a possibility of 4 over 52. Okay? And then we have the probability of an ace, and the probability of an ace successes is 4 over 52. And then we add the 2 together. Okay? And then that equals 8 over 52. Okay? And if you would punch that into your calculator, then that would be a 15% chance of getting an ace or a 2. Okay? Does that make sense? So I have this deck of 52, and I draw a card. I have a 15% chance the card in my hand is a 2 or an ace. Okay? Does that make sense? Okay? Alright, so let's try Sylvia. Okay? So we have Sylvia. She has a stack of playing cards consisting of 10 hearts, 8 spades, and 7 clubs. Okay? If she selects a card at random from the stack, what is the probability that it's a heart or a club? Alright, can it be a heart and a club? No. So they're mutually exclusive. Okay, they don't have any relation between the two. So we're going to do, what is our total number of cards that we have here? 25. Okay? So we're trying to do the probability of a heart, or, again, here's the key word, or the probability of a club. Okay? So, the probability of a heart. The probability of heart is going to be the successes of heart over our total, right? It's always successes over total for probability. So what is our success of hearts? How many hearts do we have altogether? 10. Over our total. Okay? I have the word or, so that's a plus sign. And I have a probability then of clubs. So what's our successes of clubs? It is 7. So I do plus 7 over 25. When I add those up, I get 17 over 25. Okay? So the chances of actually getting a club or a heart is about 68%. Okay? Does that make sense? Okay? So that just means if I have my 25 cards, I pick up a card out of it, I have a 68% chance that the card in my hand is either a heart or a club. Okay? Alright, flip. Alright, you guys will try this. You have a 6-sided dice to roll, and you want to know the probability of rolling a 1 or a 5. Can the roll be a 1 and a 5? No, so they're mutually exclusive, okay? So go ahead and try these two problems and see what you guys get. Okay, so again, the top one is asking you the probability of rolling a 1 or a 5, okay? So the probability of rolling a 1 or a 5 is going to be the probability of 1 plus the probability of rolling a 5. Well, what are my chances of rolling a 1 out of the die? Success of 1 is a 1, and then I have a total of 6. And then I have, what's the probability of rolling a 5? Well, the chance of rolling a 5 is 1. The success of that is 1 over 6. So that equals 2 over 6, or 1/3. Okay? What's that?
Won't you add the 6s?
No, when you're adding, the denominator does not change. Only when you multiply. So it's like if I have 1/4 of a pie and I add another 1/4 of a pie, I really have a half of a pie, right? So it's I have 2/4 of a pie. So when you guys add, like if I have 1/4 plus 1/4, so I have 1/4 and I have 1/4, that is 2/4, which is 1/2. When you add, you don't multiply the denominators. Only when you multiply do you multiply them. So if I have 1/4 times 1/4, that's like 1/16. The multiplication, you multiply them. Okay, just kind of read. Alright, so that's about a 0.3%, 33%. So what is the probability of rolling less than a 2? Well, what number, so less than a 2, what number or numbers is less than 2? Just 1. So this point is just going to be 1 over 6. If it said like less than, probability of, let's say, less than 3, well, I have 2. I give 2 and 1, right? So that my successes would be 2 over 6. Okay? Does that make sense? Okay. So questions on mutually exclusive so far? How we just add them together. Alright, so of course everything isn't as simple as it is that. We have to get into where we have multiple probabilities in a situation, okay? And so we're going to have the adding because it's an or situation, but there's multiple options. So here's an example. You have a film club that makes at least a list of 9 comedies and 5 adventures. They plan on selecting 4 titles at random to show this semester. What is the probability that at least 2 of the films they select are comedies? Okay, so we're picking a total of 4 titles, right? So we have a total of We have a total of 14 movies to pick from, right? And we're picking 4 of them, okay? Does that make sense? So this is like my N, and this is like my R, okay? Now, it says, what's the probability that at least 2 of the films selected are comedies? Well, we have the probability of where we could have 2 comedies, which means we'd have 2 comedies and 2 adventures, right? Or I could have 3 comedies and 1 adventure, because that's still at least 2 comedies, right? Or I could have a total of 4 comedies and 0 adventures. Those 3 options meet that criteria of at least 2, right? So you can see how I have 3 different ways I could pick at least 2 comedies, right? Okay. So what we need to do is we need to set up the probability of that. We're going to add it to the probability of that, and then we'll add it to the probability of that. Okay? So this is where we come in with our combinations. Okay? So I need to create a combination that has 2 comedies and 2 adventures. Okay? So it's always going to be our successes over totals. So we have to figure out, well, what's the success of 2 comedies? Okay? Well, how many comedies do I have altogether? I have 9. How many am I picking out of this one? 2, right? So if I have 2 comedies, my other option is I have 2 adventures, right? So how many adventures do I have? 5. And then how many am I picking out of this one? 2. Okay? And these are multiplied together then. So I have the probability of getting 2 out of my 9 and times the probability of getting my 2 out of my 5 for adventures. My total then is going to be, how many movies do I have altogether? 14. And how many am I picking altogether? 4. Okay? So my total is always going to be my N and my R. So what I have total to pick from, how many I'm picking altogether. Notice how when I have these 2 combinations, the total for the comedies and the total for adventures, the 9 and the 5, equal that 14. And notice how my 2 and my 2 equal my 4, right? So you're going to have as many pulled up here, should equal that down there. Okay? Alright, so that's the probability of 2 comedies. So what would our probability of 3 comedies look like? Well, how many comedies do I have altogether? 9. How many am I picking out of this one? 3. So on my adventures, I have how many adventures? 5. And how many am I picking on that one? 1. My total stays the same on the bottom. And that will always be the same. And then the next one is my 4 comedies. So I have a total of 9 comedies. I'm picking 4. And then I have 5 adventures, and I'm picking 0. And then I have the total on the bottom. Okay? So these are just plugging into your calculator. So I could do my 9C2, I times it by my 5C2, and that's going to be divided over by my 14C4. Whatever that number is, and you add to this. Okay? So if I put this into my calculator, I should get 36 times 10 all over 1001 for this first term. Okay? I'm going to add that to 84 times 5 all over 1001. What's that?
I didn't realize we're adding them all, so I started doing the second one.
Oh, and then I'm going to do 126 times 1 all over 1001. Okay, so this is my probability of the 2, this is my probability of the 3, this is my probability of the 4. So when you add this, it's 360 over 1001 plus 420 over 1001 plus 126, and that equals 906 over 1001, which is about a 90% chance of pulling at least 2 comedies. Okay? I guarantee there's something like this on the test, where you have the multiple ways where you can do that. Okay? So the thing to understand is when you are figuring out the 2 comedies, again, how do you do the combinations? Do the successes of the total of the comedies plus the successes, times the total of the adventure times, or with the, how many you're pulling, the successes of that. It's 90%, yeah, it's hard to read. Okay? Alright, so you guys try it. You have an option, you have this problem down here. There's 7 girls and 6 boys on a homecoming committee. A committee of 4 people is being chosen to decide on a theme. What is the probability that the subcommittee will have at least 2 girls? Okay? So it's the same concept of this. You're going to have a probability of at least 2 girls. Okay? And you have to figure out what the other ones will be. And try, they don't give you very much space to work on it, so you can try it down here or something if you need more space. But go ahead and give it a shot and see what you guys can come up with. Okay, so if I have a subcommittee of at least 2 girls, I have a total of 2 girls and 2 boys. Otherwise, I could have 3 girls and 1 boy, or I could have 4 girls and 0 boys. Okay, so those are my possible committees I can have of girls that are at least 2. Okay, so you have to do the success of this, add it to the success of that, add it to the success of this. So for 2 girls and 2 boys, well, how do I write that? Well, how many girls total do I have? I have 7, and of those 7, I'm picking 2. Oops, I don't know why I did C. Okay, then I have my success of boys. I have 6 total boys, and I'm going to be picking 2. Okay, my total is going to be the total of boys and girls combined, which is 13, and what I'm picking all together, which is 4. Okay, so that total is going to be the same throughout the whole problem. Okay, so you could actually just write that if you want. Okay, so my N is 13 and my R is 4. So what I'm picking up here should equal what I have down there, total. So like 2 plus 2 is 4. 7 plus 6 is 13. That works. Okay, so then I do my success of 3 girls, 1 boy. So that's going to be 7 total girls, but I'm picking 3. So then I have 6 boys to choose from, and I'm only going to be picking 1. Okay, and then I have my last one, which is going to be 7 girls total, but I'm picking 4 of those. And then on my boys, I would pick none. Okay, oops, I always do that. Okay, and if you have it where it's 0, you don't really need to include it. You just cross it out, but that way you see that you have all your numbers. Okay, so then you would just calculate those and plug them into your calculator. Okay, and I got 112 over 143, or approximately 78%. Okay, so you have about a 78% chance of getting a subcommittee of at least 2 girls. Okay, does that make sense? The bottom is I have a total of 13. This is my total to what because remember it's NCR, you guys. This is what you're doing. N is your total, and R is your sample that you're pulling out. Like, what am I pulling out of that total? So I have a total of 17 or 13. 7 plus 6 is 13, and my sample I'm pulling out is 4. Yep. Okay. Well, that's probably being reduced. I've reduced it. Yeah, this has been reduced. Okay. All right. Questions on that? Okay. So that is where you have mutually exclusive, where you can't be a girl and a boy at the same time. You can't be a 5 and a 1 at the same time. You can't be a 2 and an ace at the same time. But let's say you have it now where you have some relationship. So I could be a king and a spade at the same time, right? So what are the chances of picking a king or a spade? Well, there's that overlap where it's a king of spades, right? So now we have what's called inclusive events, where 2 events are not mutually exclusive, meaning there's a relationship, okay? There's some sort of relationship, or overlap as we put it, okay? And so it's the exact same process, except for then at the end you have to subtract out where they do have the commonality, okay? So you're going to have the same thing where it's going to be A or B. So it's going to be the probability of A plus the probability of B, and then you subtract out the probability of where they're A and B. Okay? So if I have if I have like a 2, if I say a probability of 2 or a heart, okay, I'll have the probability of a 2 minus the probability of a heart, or plus the probability of a heart minus the probability of when it's the 2 of hearts. Okay? So what's the probability of a 2? How many 2s are there in a deck of cards? 4, so that's going to be 4 over 52. How many hearts are in a deck? How many are in a suit? You guys remember? 13. So it's 13 over 52. Okay? But then how many 2 of hearts are there? 1, right? So I have to subtract out that 152. Okay? Because otherwise you're counting for that twice and you don't want to. So at this point it would be 17 50 halves, whatever, minus 1. So it's going to be 16 over 52. Okay? So you want to subtract out that, this is where you're subtracting out the double of it. Okay? Alright, so let's look at this example here. We have 2,400 subscribers to an internet service, 1,200 own brand computer A, 500 own B, and 100 own both. So here's the question to you guys. How many of you guys have like a Windows PC? Show of hands. Windows PC at home. Like a laptop or computer. How many of you guys have a Mac? Does anyone have both? You guys would be the ones we'd subtract out. Okay? That's what they're trying to ask for. Okay? So, we want to know what is the probability a subscriber selected random has either A, again, or, which tells us plus, B. Well, there is some overlap because there's a both here, right? So we're going to do the probability of A or B. Okay? But since there's overlap, we'll do the probability of A plus the probability of B, bless you, minus the probability of A and B. Okay? So, probability of A, the successes of A's. How many A's do we have all together? We have 1,200. Okay. How many, what's our total? How many total computers do we have? 2,400. Okay. So what's the probability of B? How many B computers do we have all together? We have 500. Okay. How many computers total do we have? 2,400. And then, what is our success of A and B? How many A's and B's do we have all together? We have 100. A and B right here. Okay? And so that's over our total. Okay? So that would be 1,700 minus 100, so that's going to be 1,600 all over 2,400. And so that equals about a 2/3. So 2/3 of this population have a computer A or B brand. Okay? You could. Yeah, and you guys, the test is multiple choice. So if it's in percentage, you just need to know to take your fraction to convert it. If it's a fraction, then you just need to know which one it is. Okay? You always can take your fraction and convert it to a percentage to know if your fraction equals another fraction. Does that make sense? So if like you didn't reduce it down, let's say you had 1,600 over 2,400. If I take 1,600 and divide by 2,400, I should get the same answer if I take 2 and divide by 3. So if you're not sure if your fraction is the fraction on the page, divide them and you'll see which ones actually have the same percentage. Okay? Standard deck of cards was the probability of picking a king or a spade. So go ahead and try that one out for you. So basically, when you see this, you see or, which tells you it's going to be a plus. So you have to then decide, is there any relationship between the two? Can a king be a spade or a spade be a king? Can we can we have a king of spades on a card? Yes, you can. Okay, so therefore, like you can't have a 2 and an ace on the same card, but you can have a king and a spade on the same card. So therefore, it's inclusive. So once you see an or, you know it's going to be a plus, and then you have to decide if it's mutually exclusive or inclusive. If it's inclusive, you have to subtract out the commonality. Okay? If it's mutually exclusive, you don't subtract it out. So give it a shot. Alright, so you guys, we did just kind of do this one, so I'm going to go over this real quickly. Alright, so, again, identifying what you have to do, what type of problem is going to be the #1 challenge. So I'm trying to give you little tidbits. When you see the word or, it's the plus, so you're adding probabilities. then you have to evaluate if they have anything, can they be any overlap. There can be with king and spades, okay, so I can have kings, I can have a spade, and I can have a king of spades. So I'm going to do the probability of a king plus the probability of a spade, and then I'm going to subtract out the probability of the king of spades. Okay? So what's the probability of a king? How many are in a standard deck?
4.
There's 4 out of 52. Okay? How many spades total can I have in a deck?
13.
13. And that's over 52. And then I'm subtracting out how many king of spades are in a deck?
1.
1 out of 52. So when you add those together, you get 16 out of 52. And then you can reduce that down. And then your percentage is 30.76%. Okay, so you have a 30% chance of getting a king or a spade. Okay? Alright, so what we're going to do on the next problems down here, you guys, is we're going to go through and decide if they're mutually exclusive or not, and then we want to set it up, and then I'll have you guys calculate the probability separate. I just want to make sure we get the setup. To me, the setup is what counts. You all can plug everything into your calculator probably pretty easily. Yes?
Okay, so figuring out if it's between.
Alright, so let's look at these. So a bag contains 45 dyed eggs. You have 15 yellow, 12 green, and 18 red. What is the probability of selecting a green, or there's that or, so we're going to plus a red egg. So we have the probability of a green, we have a probability of a red. Okay? So you can't have a green and a red egg at the same time. There's not a mixture. If it said, well, then you have a couple of green and red eggs, you don't. So therefore, it's mutually exclusive. Okay? And if you guys can't remember exclusive versus mutually exclusive versus inclusive, I mean, I don't know if you've heard this or not, but pretty much if you're, quote, just dating one person, you say that you're exclusively dating that person. I mean, like, it's just you and that person. You're not seeing 5 other people, okay? So when it's like that is just one event, okay? There's no overlapping there, okay? So the probability of green. So again, it's probability of success over totals, okay? So what's my success of greens? How many do I have altogether? I have 12, and then what's my total number of eggs? 45. Okay? What's my successes of red? 18, and then I have a total of 45. So at this point, I have 30 over 45 eggs. It is 2/3, which is approximately then 66%. Okay? So I have a 66% chance of picking a green or a red egg. Okay? The question comes up, you guys, and I'm just going to kind of mention this right now, is when do you do this, just a solid number, versus when you do the combination, such as like 12C, let's say 3. If you're choosing all of the items, so this says selecting a green egg, there's no limit on it. You're just going to do what you have for your success, which is 12. If it said, what's the probability of selecting 2 green eggs? Well, notice how 2 is not all of 12. When you are taking less of what you have there, that's when you turn to the combination. Okay? So notice how it's 12 green, right? It doesn't put a limit on the green or the red. Okay? But let's say I said, what's the probability of picking 2 green or, let's say, 5 red? Okay? Well, I have a total of 12 green, and I have a total of 18 red. Okay? When what I'm picking is less than what I have out there, that's when you have to do the combination. Okay? So that's when you have to switch. Okay? Alright. Hopefully that didn't confuse you. Alright, what is the probability of drawing a red card or an ace from a standard deck of cards? So how many do I have in a standard deck of cards? 52. How many red cards do I have altogether?
26.
I do have 26 because I have diamonds and I have hearts. Okay? What's the probability of picking an ace? Or how many aces do I have in a standard deck of cards? I have 4. Okay? So, I want to know drawing a red or an ace, so I have a plus right there. Okay? So the probability of a red plus the probability of an ace. Okay? Is there a possibility that an ace can be a red card?
Yes.
Yeah, so therefore I have overlap. Okay, and so how many red aces can I have?
2.
I can have 2 of those. Alright, so I have to subtract the probability of a red ace. Alright, so how many reds do I have altogether? 26 over 52. I have a probability of an ace, which is 4 over 52. And I'm going to subtract out the red aces, which are 2 over 52. And when I do that, I should get 28 over 52. Which is about a 53.8%. Okay? Is this one mutually exclusive or inclusive? It is inclusive. Okay? Alright, the letters of the alphabet are placed in a bag. What is the probability of selecting a vowel and one of the letters from the word quiz? So, let me ask you, is this mutually exclusive or inclusive? So, what are vowels? A, E, I, O, U. Okay. Are any of those in this word quiz? Yes, so therefore, is it mutually exclusive or inclusive? It's inclusive. Okay, go ahead and try and set this one up. Alright, so, again, you're looking at the letters of the alphabet. How many letters are there in the alphabet? 26. So that's my N. Okay? So it wants to know the probability of selecting a vowel, so probability of a vowel plus the probability of quiz. Okay? Is there any overlap between the two?
Yes, there's 2 letters.
There is. There's 2 letters, U and I, so we have to subtract out that probability of U and I. Okay? So this is inclusive. So the probability of vowel is going to be 5 over 26. The probability of getting quiz is 4 letters, so 4 over 26. And then I'm going to subtract out my U and my I, which is 2 over 26. So that should equal 7 over 26. Okay? And that's about a 2.7%. Okay? Alright, then the letters of the word love and live are placed on cards and put in a box. So how many cards are put in a box? How many cards are put in the box? 8. So my N is 8. Okay? What is the probability of picking an L? And what's the probability of picking an O? Can I pick, is an L or an O the same on the same card? No. So this is mutually exclusive. Okay? So the probability of picking an L, how many L's do we have in there? 2 out of 8. How many O's do we have? We have 1. So the probability of picking an L or an O is 3 out of 8. Which is approximately 37.5%. Okay? So just over 30%, for almost 40%. Okay? So questions on the fact that we're mutually exclusive. When we're adding probabilities, we're dealing with or something. Okay? We want to add the probabilities of the 2 items together. Okay? If you have where you have multiple options, so at least, when you have at least, you're going to have these multiple combinations. Okay? And then you have it where it's inclusive, meaning they have some overlap, so you have to subtract that overlap out. Okay? So that's kind of the lesson today. Alright, so A60 is 12.5. Kind of hard to read. You have 13 through 35 odd. Okay? You want to skip 27, so don't do 27. Okay? Questions on this one down here, on world cultures, you guys, assume this has 8 sides. Okay? 33 and 35, assume that this weird dice has 8 sides. Okay, 33 and 35. Okay, it talks about a cane dice, and we're just saying they have 8 sides. Okay? Alright? So, you have about a half hour to get a lot of this done.